Okay, guys, good evening and welcome back to Electric Circuits. So, in the last session, we have discussed about the second energy storage element, namely the inductor. So, for the inductor, we derived several relationships between current and voltage, and we also found the energy stored in the inductor in terms of the current flowing through the inductor, and the other important property, which is that the current through the inductor cannot change suddenly or instantaneously. And also, towards the end of the last session, we looked at something called DC steady state. First of all, any circuit connected and left for a long time, any circuit connected and left for a long time will reach what? Steady state. And if the circuit is driven by only DC sources, if the circuit is driven only by DC sources, then after a long time, the circuit will reach what is called DC steady state. And at DC steady state, any circuit or any system at DC steady state, all voltages and currents are going to be DC. That is the property of any circuit at DC steady state. I'll say it again. Any circuit at DC steady state, every voltage and every current will become what? Constant. Every voltage and every current will become constant. Constant, it means what? It does not vary with time. Voltage constant, is it not a DC voltage? Current constant, is it not like a DC current? So all voltage and currents at DC steady state will be what? DC in nature. And because all voltage will remain constant, even the voltage across the capacitor will remain what? Constant. If the voltage across the cap remains constant, then the current through the cap always has to be zero. Only then the voltage across the cap will remain constant. That is why we say that if any circuit is at DC steady state, then each and every capacitor in that circuit, if any circuit is at DC steady state, each and every capacitor in that circuit will behave like an open circuit, because current through each and every capacitor is going to be zero. Current always zero. That element behaves like what? An open circuit. Okay. And then when it comes to the inductor, even for the inductor, the current will remain what? Constant. Now for any inductor, if the current remains constant, then the voltage across the inductor has to be zero. Again, if the circuit is at DC steady state, then each and every inductor in that circuit which is at DC steady state will behave like a short circuit. Why short circuit? Because the voltage drop across every inductor is going to be zero, and of course in that short circuit any amount of current can flow. Okay, so the bottom line is what? At DC steady state, if the circuit reaches what? DC steady state, then every capacitor will behave like an open circuit, and every inductor will behave like a short circuit. So this is pretty much what we learned in the last session, and then we started solving a few problems related to what? Inductor. In this session also, we will continue to solve a few more problems related to inductor. Once we finish off problems on inductor, then immediately we'll get started with first order circuits. Okay, so in the next 30-40 minutes, let us solve a few problems on inductor. So on the screen, you can see the first question. So here we have what? An inductor whose value of inductance is what? 100 millihenry. So on the screen, you can see the inductor whose value of inductance is what? 100 millihenry. The value of L is what? 100 millihenry. Voltage across the inductor is what? Denoted by VL. Current through the inductor from plus to minus is what? IL. What is given for the inductor? The voltage drop is given. It is what? Some 2 times e power minus 3t volts. 2 times e power minus 3t volts. Is it not an exponentially decaying voltage? Yes or no? 2 times e power minus 3t. It will exponentially decay with time. And the other thing that is given is what? That the current through the inductor at a specific instant, current through the inductor at some specific instant, what instant? At t equal to what? Minus 0.5. Current through the inductor at t equal to what? Minus 0.5. It is given as 1 ampere. So given the voltage across the inductor as a function of time and the current through the inductor at one particular point of time, which is what t equal to minus 0.5 seconds, you have to find what the current through the inductor as a function of time. I mean, there is something which we had already done in the last session. I mean, we had solved a similar model in the last session. Please try to find IL as a function of time. Take 2 minutes and find IL as a function of time. Do it. Okay, please look at the screen, all of you. What is given for the inductor? The voltage drop is given. You have to find the current as a function of time. Always the starting point, it is what? Voltage in terms of current. You know, for any inductor, VL is what? L times dIL by dt. And this can be written as what? dIL by dt equal to what? VL divided by L. And this can again be written as what? dIL equal to what? VL by L times dt. Yes, I hope it is very clear up to this point. dIL is equal to what? VL divided by L times dt. Now, since the value of the inductor current at a particular point in time is what given, for this equation we should perform what? Indefinite integration. Okay. So you know the meaning of indefinite integration. We just integrate on both the sides without substituting any lower limit and upper limit for the integrals. But then in the end, on one side we add some constant of integration. And to find the constant of integration, we can use the given value of the current at this instant, that is what? T equal to minus 0.5. That is how you will get the value of the constant of integration. Anyway, look at this. So in place of VL, right hand side of this equation, in place of VL, let me write the given expression for VL, which is 2 times e power minus 3t divided by L. L is what? 100 millihenry. 100 millihenry is what? 100 into 10 power minus 3. What is 100 into 10 power minus 3? Is it not 0.1? So what I will do, I will directly write the value of L as what? 0.1. That's all, dt. Now integration of dIL, it is what? Simply IL. Yes or no? In fact, IL of t. What is the integration of 2 e power minus 3t by 0.1 with respect to time? First of all, 2 by 0.1 is what? 20. 20 you can get it out of the integration. And then the integration of e power minus 3t will be what? Minus 1 by 3 into e power minus 3t. Okay. So is it not going to be minus 20 by 3 e power minus 3t, because we are doing what? Indefinite integration. On the right hand side, let us add a constant of integration, which is denoted by k. Now we have to find the value of k, for which we will make use of this value of IL. So in place of t, let us substitute minus 0.5. So IL at t equal to what? Minus 0.5 will be equal to what? Minus 20 by 3 times e power minus 3t. See here, in place of small t, you should write minus 0.5. Minus 3 into minus 0.5 will be what? Plus 1.5. Correct, right? Minus 3 into minus 0.5 is going to be plus 1.5 and then plus k. And in the equation, the given value of IL at t equal to minus 0.5 is what? 1. That's all. From here, you can get the value of k. I hope you also got the same equation. So if you got the same equation, can you please tell me what is the value of k? Anybody? 30.87. Very good. Very good. So the value of k is what? 30.87. That's all. You are done. Once you find the value of k, now we can write the complete expression for IL of t. Minus 20 by 3. What is 20 by 3? I think 6.67, right? So minus 6.67 times e power minus 3t plus k, the value of k is what? 30.87 units amperes, okay? Please verify if you also got the same final expression for IL of t. IL of t is what? Minus 6.67 times e power minus 3t plus 30.87 and the units are what? Amperes, okay? I think Dineshwaran got the same answer, right? Very good, very good. So I hope everybody followed this solution, okay? Okay, look at this circuit. What do you have in this circuit? Are we not having a resistor in series with an inductor and both are in series with a current source? What is the value of the current source? 12 sine pi t by 6 amperes. So what type of current source is this? DC or AC? 12 sine, is it not a sinusoidal current source or AC current source? So in this circuit we have a resistor and an inductor connected in series across what? A sinusoidal current source whose value of current is what? 12 sine pi t by 6 amperes. Resistance value is what? 0.1 ohms and the inductance value is what? 3 Henry. The question is what? To find the maximum energy stored in the, it's extremely easy. Just tell me the answer. Take half minute and tell me the value of the maximum energy stored in the inductor. It's a 5-second question. Not even 5 seconds, 1 second. Come on, type in the chat box. Okay, 216, that's all. You see, because in this circuit, all the three elements are in series, obviously they'll have the same current. So the current through the inductor is also what? The IS, okay? Now for IS, what is the peak value? Is it not 12 amps? Yes, so it's 12. It is what? IM. For every sinusoidal current or sinusoidal voltage, there will be a maximum or a peak value, yes or no? Yes. And for this given sinusoidal current, the peak value is what? 12 amps, okay? So IM, it is what? 12 amps. And you know, WL is what? Half L IL square, and WL max, because in the equation we have been asked to find the maximum energy stored in the inductor. WL will become maximum and the current through the inductor also becomes what? Maximum. So half L IM squared. So half into the value of the inductor is what? The value of inductance is what? 3 Henry. And then IM square is what? 12 into 12, which is 144. That's all. 144 by 2 is what? I think 72. 72 into 3, it must be 216 joules. That is the peak or the maximum energy stored in the inductor. So maximum energy will be stored in the inductor if the current through the inductor is what? Maximum. Similarly, maximum energy will be stored in the capacitor when the current through the when the voltage across the cap is what? Maximum, okay? Moving on to the next question. So what is given in this circuit? We have what? 3 elements in parallel. Do you all agree with that? We have a voltage source across which there is a resistor and also an inductor. So all 3 elements are in parallel. They'll have the same voltage drop. The value of the input voltage source is given. It is what? 40T. What kind of voltage is this? Input voltage is what? 40T. Is it DC or AC or some other thing? It has got a name. If the input voltage is what? 40 times T and T is what? Greater than 0. It has got a name. Can somebody tell what that name is? What is the name of this input voltage if its value is what? 40T. 40T ramp. Is it not a ramp? 40T, will it not linearly increase with time? So the input voltage if you plot it versus time, it will linearly increase with time. Anything that linearly changes with time, it is what a ramp. If it linearly increases with time, it is called a positive ramp. Whereas if it linearly decreases with time, it will be called as what, negative ramp. But this one is what, 40t plus 40t, it is definitely a positive ramp. Had it been minus 40t, then we should say the input voltage, it is what, a negative ramp. Anyway, apart from this, what else is given? IL of 0 is also given. What is it? IL of 0. What is this IL of 0? Is it not the initial current through the inductor? Initial current through the inductor is what given. So given the initial current through the inductor and also the applied input voltage, which is 40t, you have to find what? In of t. What is this in of t? In of t, is it not the current drawn from the input source? In of t is what? The current drawn from the input source. See here, two things, okay? Resistor is what? Connected across the input source. Resistor connected across a voltage source, resistor will draw some current. Inductor also connected across what? The same input source, even the inductor will draw some current. Now resistor will draw some current, inductor also will draw some current. Now the total current drawn from the input source, will it not be sum of the currents drawn by the resistor and the current drawn by the inductor? Yes. So here you can call this as what? IR, and you can call this as what? IL. So here clearly IN is equal to what? IR plus IL. Okay. I mean, it's very easy to identify that the total current drawn from the input source, it is what? The current drawn by the resistor plus the current drawn by the inductor. What is the current drawn by the resistor? You see, because both are in parallel with the input source, Vin, it is also what? The drop across the 10 ohm resistor. Okay. So IR, it will be equal to what? Vin by R. IR will be equal to what? Voltage divided by resistance, Vin by R, plus IL of t. Now it's all about finding what? IL of t. Again, you know, for an inductor, you have this relation, right? IL of t is equal to what? IL of 0 plus 1 by L integral VL of t dt from 0 to t. I hope all of you can recall this expression for IL of t in terms of what? The initial current through the inductor. IL of t is what? IL of 0 plus 1 by L integral 0 to t VL of t dt. That's all. So here IL of 0 is already given. It is how much? 5. And then 1 by L. L is also what? 5. 1 by 5 integral 0 to t. What is VL? It is 40t and then dt. What is the integration of 40t? Integration of 40t, is it not 40t square by 2? 40t square by 2 is what? 20t square. 20t square divided by 5 is what? 4t square. 4t square from 0 to t will be equal to what? 4t square. That's all. So it is what? 5 plus 4t square. So that is what? IL of t. That is what? IL of t. Now again, coming back to this equation for IN. So IN, it is what? Vn by R plus IL of t. What is Vn? 40t. 40t divided by R is what? 10 ohms. 40t by 10 is what? 40. Okay. So 40 is what? The current through the resistor plus the current through the inductor, which is 5 plus 4t square. Okay. 5 plus 4t square. That's all. This is valid for t greater than 0. Understood? This is the final expression for the total input current drawn from the input voltage source, that is what? IN, which is equal to what? Sum of the currents drawn by the two elements, resistor and the inductor, which are directly connected across the input source. 4t plus 5 plus 4t square. Okay. Units will be amps. Okay. Well, look at the next circuit. So if you look at this circuit contains what? a resistor whose value is what, 10 ohms, and an inductor whose value is what, 5 Henry. Look at the resistor and the inductor, both are in series, connected across what? A current source. Both are in series, connected across what? A current source. Is it not a single loop circuit? And in a single loop circuit, the current will be what? Same for all the elements. So what is the current flowing in this loop? It is Is, okay? And the Is value is what given? 0.4 T square. So how does the input current vary with time? It varies parabolically with time. It will increase with time like a parabola, okay? 0.4 T square, okay? And what are you asked to find? You have to find what? Vin of t. What is this Vin of t? Vin, it is what? The voltage across the current source. Now this Vin of t, let's say the voltage across resistor is what? VR, okay? Let us say the voltage across resistor is what? VR. And let us say the voltage across the inductor is what? VL, okay? Now, can't we write KVL around this loop? If you write KVL around the loop, won't you get Vn equal to what? VR plus VL. It should be right. Voltage across resistor plus voltage across inductor will be equal to what? The input voltage, KVL, okay? Now, the same current Is will flow through what? Both the resistor as well as the inductor. So first, let us find VR. So VR, is it not equal to Is into R? And what is Is? It is 0.4 T square into R is what? 10. 0.4 into 10 is what? 4 T square. So VR is what? 4 T square. And VL, see, even for the inductor, the current is what? The same Is. If you know the current, you can easily express the voltage in terms of current VL. Voltage across inductor, you know, it is equal to what? L times dIL by dt, which is same as what? L times dis by dt. Again, L is what? 5. What is dis by dt? Given that I is what? Is is what? 0.4 T square. 0.4 T square derivative is what? I think 0.8 T. So 5 into 0.8 T. That's all. So 5 into 0.8 is what? 4 into T. Once again, our Vn is what? Voltage across resistor, which is 4T square, plus voltage across inductor, which is 4T. Add these two, you'll get the complete expression for the input voltage, okay? So 4T square plus 4T, units are volts, okay? It's a very simple problem, okay? Look at the next circuit. Again, this circuit, it contains what? Plenty of energy storage elements, okay? In fact, there is what? The first inductor, 1 Henry. Then we have the 2 Henry coil, which is the second inductor. We also have the 3 Henry coil, which is the third inductor. So how many energy storage elements are there in this circuit? There are 3 energy storage elements. And how many independent sources are driving this circuit? There is only one independent source driving this entire circuit. That is what? The 100 volt source, which is what type of source? Is it not a DC source? So the only source driving this circuit, it is what? A DC source. And look at the given statement. Circuit connected and left for a long time. If any circuit is what? Connected and left for a long time, that is, it is understood that circuit will reach what? Steady state. Circuit, after a long time, it reaches what? Steady state. Because the source is what? DC. So after a long time, circuit reaches what is called DC steady state. So when the circuit reaches steady state or DC steady state, you should find the values of what? I1 and I2. I1 is what? The current through the 2 Henry coil, and I2 is what? The current through the 3 Henry coil. Please find the values of I1 and I2. Type in the chart box the values of I1 and I2. The only thing that you must use in this question is what? The fact that at DC steady state, all inductors will behave like what? Short circuits, okay? So at DC steady state, at DC steady state, inductor, it behaves like a short circuit. So this problem is entirely based on this fact. Okay. Okay, Dineshwaran is saying the values of I1 and I2 are 5 and 4. What about others? Others also, please tell me your values for I1 and I2. Please tell me the values of I1 and I2. I mean, it is very straightforward because the circuit reaches what DC steady state. All you have to do is to make every inductor a short circuit. Make every inductor a short circuit. Okay. So if you look here, this 1 Henry coil, it becomes what, a short circuit. 2 Henry coil, it becomes what, a short circuit. 3 Henry coil also, it becomes what, a short circuit. That's all. At DC steady state, every inductor becomes what, a short circuit. Okay. Now, when this inductor becomes a short circuit, you should be able to identify that this 80 and 20 both are in parallel. 80 and 20 both are in parallel. In fact, not just 80 and 20, 80, 20 and 16, all three are in parallel. And this entire parallel combination, it is in series with 2 ohm. Okay. So our circuit will look something like this. So first I'll draw the 100 volt source. Then let me draw the 2 ohm resistor. Then we have the 16 ohm resistor. volts, 2 ohms, then the 16 ohm resistor, and then we have the 20 ohm resistor, and then we have the 80 ohm resistor. Okay. And here if you look at I2, this I2, it is also what, the current through the 80 ohm resistor, because 80 and the 3 Henry coil both are in series. This current is also what, I2. So whatever current flows through 80 ohms, that is nothing but I2. And I1 is what, the current flowing in this piece of wire. So even in this circuit, current in the same piece of wire will be what, I1. So now in this simple resistive circuit, we have to find what, I1 and I2, which is very easy. Okay. So first let us find the current drawn from the voltage source itself. What is the current drawn from the voltage source? How do you find the current drawn from any voltage source? Divide the voltage by the net resistance across the voltage source. First 80 and 20 both are in parallel. What is 80 parallel 20? 80 parallel 20, it must be 16. It must be 16. Yes, 80 parallel 20, it must be 16. Then 16 and 16 both are in parallel. 16 parallel 16 is what, 8. Then 8 will be in series with 2. 8 in series with 2 is what, 10. So what is the net resistance across a 100 volt source? It is 10 ohms. 100 volts divided by 10 ohms is what, 10 amps. That means the current drawn from the voltage source, it is what, 10 amps. Okay. So what is this current? It is 10 amps. Now what is the net resistance of this network? 80 parallel 20, it is what, 16 ohms. Okay. Now look at this. This 10 amps, is it not getting divided between this 16 ohms and also this network whose resistance is what, 16 ohms? This 16, this entire network, this part of the network also has a resistance of what, 16. So this 10 amps will get equally divided between this 16 ohms and this part of the network which also has a resistance of 16 ohms. So what is this current? It is going to be 5 amps. And what is this current? It is again going to be 5 amps. And then what? This 5 amps will get divided between 20 and 80. We are interested in the current through 80. You know, current through 80 will be proportional to what? 20. So what is I2 going to be? I2 will be equal to what? What is that current which is getting divided between 80 and 20? It is 5 amps. Current through 80 will be proportional to what? 20 divided by 20 plus 80. 20 plus 80 is what? 100. 20 by 100 is what? 1 by 5. So I2 is what? 1 amp. So as you said, I2 is what? 1 ampere. And I1 is what? 5 amps. Okay, that's all. So what are the final values of I1 and I2? I1 is what? 5 amps. I2 is what? 1 ampere. Clear, right? All I did is to draw the circuit at DC steady state, wherein I replace every inductor with a short circuit. Then it becomes a simple resistive circuit. It's all about finding the different currents or the different branch currents. Sorry. Okay, look at this question. So once again we have a circuit. Once again we have a circuit that has what? Several energy storage elements. In fact, let us simply count the energy storage elements in the circuit. First we have the capacitor, then we have the inductor, then again we have the capacitor, then inductor, again capacitor. I think there are 3 capacitors and 2 inductors. Okay, so altogether in this circuit there are 5 energy storage elements. Again the statement is what? Okay, 1 second. Again the statement is what? Circuit connected and left for a long time. Find V1 and V2. Find what? V1 and V2. What is this V1? It is the voltage across the 1 farad capacitor. And where is V2? V2 is what? Voltage across the 3 farad capacitor. Again, what is the only source driving this circuit? Is it not this 100 volt source? Which is what type of source? Which is a DC source. Because a DC source is what driving the network. And if the circuit is what? Connected and left for a long time, it will reach what? DC steady state. Okay. So once again, this means circuit reaches what? DC steady state. You know, at DC steady state, cap becomes open, inductor becomes short. Again, please tell me the values of V1 and V2. Every capacitor becomes what? An open circuit, and every inductor can be replaced with a short circuit. Okay. Okay, please look at the screen. So in this circuit there are both the capacitor as well as the inductor. At DC steady state, capacitor behaves like what? An open circuit, and the inductor will behave like a short circuit. Okay. So here this 1 millihenry coil, it becomes what? A short circuit. Even this 2 Henry coil, it becomes what? A short circuit. And then this 1 farad capacitor becomes what? An open circuit. Even the other 2 capacitors will tend to behave like open circuits. Okay. Let me try to draw the circuit at steady state. Actually, we don't have that much space. So first I have drawn the 100 volt DC source. After that we have the 100 kilo ohm resistor. Then we have the capacitor. Which capacitor? The 1 farad capacitor, which will behave like an open circuit. So you can see I have replaced the capacitor with an open circuit. Remember, for an open circuit, always the current is what? 0, because there is no path for current to flow. But across open circuit, that is what? Between these 2 points, you can have any amount of voltage drop. Okay. And in fact, that voltage drop is what? V1. Okay. So V1 is what? This open circuit voltage. And then we have a short circuit, because this 1 millihenry coil, it becomes what? A short circuit. And then we have the resistor, whose value is what? 40 kilo ohms. And then we have the 2 farad capacitor, which becomes an open circuit. Then we have a short circuit, because this 2 Henry coil becomes what? A short circuit. And then we have the 25 kilo ohm resistor. And then we have the 3 farad capacitor, this one, which also tends to behave like an open circuit. And across this open circuit, the voltage drop is what? V2. That's all. Now here, what is the current? Okay. What is the current in this branch? In fact, here we have what? An open circuit. Through an open circuit, no current will flow. In fact, current in this entire branch, current through this open circuit, current through 25 kilo ohm, everything will be zero because this branch contains what? Two open circuits, no current will flow. So this current is what? Zero. What is the current through this open circuit? Again it is what? Zero, which means 100k and 40k, are they not in series? Yes or no? 100k and 40k both are in series. Whatever current flows through what? 100k, the same current also flows through what? 40k, and 100k and 40k are in series across what? The 100 volt source. Okay, resistors in series across a voltage source, you know, voltage division will take place. So what is the voltage drop across the 40 kilo ohm resistor? Voltage drop across the 40 kilo ohm resistor will be what? 100 into 40 divided by 100 plus 40. Yes. And by the way, this open circuit, is it not directly across the 40 kilo ohm resistor? So this V1, it is also what? The drop across the 40 kilo ohm resistor. So V1, which is this open circuit voltage across the 1 farad capacitor, it is also what? The voltage across the 40 kilo ohm resistor, and 40k and 100k both are in series with the 100 volt source. We will just apply voltage division. Okay, so V1 will be equal to what? 100 volts into 40k divided by 100k plus 40k, which is 140k. So I think it is 400 by 14. It is what? 400 by 14. 100 into 4 divided by 14. 400 by 14, it must be, I think all of you said 20 something, right? Is it 28.57? 400 by 14 is what? 28.57. Okay, I believe everybody got the same value for V1. That is what? 28.57. The other thing you have to find is what? V2. The other thing you have to find is what? V2. Okay, now that we found V1, let us find V2. You see here, the thing is what? What is the drop across 40 kilo ohm? It is 28.57 volts. Now, across this 40k, we have this capacitor which becomes what? An open circuit. Then we have the 25 kilo ohm resistor. Can you tell me what is the drop across the 25 kilo ohm resistor? Will it not be zero? Because the current through the resistor, it is going to be zero, because resistor, it is in series with an open circuit. Anything in series with an open circuit, current will be zero. Current through resistor zero. Current through resistor zero. Then even the voltage drop across the resistor will be what? Zero. See what we can do? We can assume the voltage drop across this open circuit to be some V3. So look at this carefully. Look at this carefully. Drop across this open circuit, let it be V3. Then drop across 25 kilo ohm is what? Zero, since the current is what? Zero. And drop across this open circuit is what? V2, and that is what we have to find. And the drop across 40k is what? V1. Drop across 40k is what? V1. Now here, are we not having some kind of a loop? Are we not having some kind of a loop? If you write KVL around the loop, won't you get V1? That is what? This voltage equal to this voltage plus this voltage. It should be, because minus is what? Connected to plus. You know, whenever minus is connected to plus, you can add the voltage. Even if you start at this point and write KVL around this loop, you will get what? V1 equal to V3 plus V2. V1 equal to what? V3 plus V2. I hope this point is clear to everybody. So voltage drop across 40k will be equal to what? Drop across this open circuit plus the drop across the other open circuit. See, you cannot say that this entire V1 will only appear across this open circuit. It can't be, right? This V1 will get divided between the two open circuits. But remember, it is not actually an open circuit. What we have here is what? A capacitor, which will behave like an open circuit. And here also we have what? A capacitor which will behave like an open circuit. So it is like this. So the actual thing is what? Like this. It is like having two capacitors. It is like having two capacitors across a voltage drop of what? V1, across a voltage drop of V1. So V1 is what? The net voltage drop. And the first capacitor is what? 2 farad. The second capacitor is what? 3 farad. And the drop across 3 farad is what? V2. Drop across 3 farad is what? V2. What is this? Tell me. We have this voltage drop, and then across this voltage drop we have 2 capacitors in series. Can you please tell me what is actually taking place in this network, in this blue color network? What will actually take place in this blue color network? What will actually take place? Voltage division, capacitive voltage division. Why current division, Sainath? Current division only in parallel, yes or no? Current division only when you have elements connected in parallel. But here the 2 capacitors, they are connected in series. Voltage division will take place. And what do we know about capacitive voltage division? Voltage across one capacitor will be directly proportional to the other capacitance, okay? And here V2 is what? The drop across the 3 farad capacitor. So V2 is equal to what? V1 into drop across 3 will be proportional to what? 2. So V1 into 2F divided by 2F plus 3F. That's all. V1 is what? Drop across 40K, which is 28.57. 28.57 into 2 by 5. Someone please tell me the value of this. 28.57 into 2 by 5. .57 into 2 by 5, 11.4, okay? Yeah, it is correct, 11.4 volts. So what are the final values of V1 and V2? V1 is what? 28.57 volts. V2 is what? 11.4 volts. Is it clear how we got the value of V2? You cannot directly say that V2 is equal to what? V1, that is 28.57. Here capacitive voltage division will take place, okay? So this is the kind of network we are going to have. So I would like to assume that everybody understood how we obtained the values of. So this sort of completes our discussion on capacitor and inductor. Now we will get started with first order circuits, okay?